Okay, welcome to our lesson for today. Actually, our first lesson of the year in math. Let's hope this works. We're going to give it one more shot. Let's hope this camera's working. They put us up in a model apartment to let us at least use it. So hopefully this works a little bit better and the camera starts working better. So anyway, let's go ahead and get started. First of all, this is going to be our first lesson. As you can see up here, 1-1, and I have the title about what we're learning about today. I'm going to be taking these notes on graph paper. I like graph paper the best because it has these grid that I will be able to keep everything sort of organized. I'm not the best artist, so this is what I like to do. Now, when it comes to you at home, you can use whatever you want. However, I do want you to write these notes out by hand. I know we're doing an all online digital class. We're saving enough trees. Let's go ahead and write these notes down. So once I finish this, I'm going to hole punch it, and I'm going to go ahead and put it in a binder, and then keep that binder safe and organized. So you should be doing that exact same thing when it comes to these math lessons. We're going to be doing them in order for the most part. Anytime we do a workshop, I will label it like this. If there's one done at home, you just need to label it for whatever section you're covering that day. So today we're going to do rational numbers, opposites, and absolute value. As I go ahead, you'll see that I have a lot of colored markers. One of these strategies we have here at OPA is that we're doing, we like to have our spatial intelligence used quite a bit when we're doing our notes. So we want to color code our notes. You can color code them any way that you want. Try not to write all in pencil though. We want to get a little color in there to help our minds work. If you really are against it, then fine, go ahead and use whatever it is that you want. We're also going to be going through every single time, we're going to be going through 7 steps. Now, when I'm doing it in a workshop, since these are online, we're going to be doing 6 steps, but there are 7 steps total. The first one we're going to do is called the anticipatory set. And the anticipatory set sort of gives us an idea of what we're learning about, sort of helps us think about it in a way that's not just notes, not learning. So today, since it is football season, we're going to go ahead and talk for a second about football. Specifically, we're going to talk about Mr. Barry playing football. Back in high school, I played with a team called the South Pass High School Tigers. That was my team, and we played, one of our rivals was the San Marino Titans, and I hated the San Marino Titans. So one year, my senior year, we went and played San Marino. And in this game, I had the greatest catch of my life. I played receiver. So I'm going to go ahead and tell you that story right now. So if you don't know football, that's okay. I'm going to explain it. Each of these marks is 5 yards, 20, 25, 30, 35, and 40. So when we started with the ball, or we had the ball, when this happened, we were on the 40-yard line. So I'm just going to draw from the 40-yard line in. We were on the 40-yard line. The way team sort of sets up is that wherever the ball is, then we have some players around it. So we have the center, 2 guards, 2 tackles, a tight end, a quarterback who throws the ball, a running back, I had 2 receivers over here, and then I was over here. This was my position. So our play that we were going to run against San Marino was that this receiver was going to go deep, this receiver was going to run like that, this tight end was going to turn and run this way, and then my route was going to go up here, out up there. So I went about a little over 15 yards, broke down, and then ran to the sideline. Our running back was going to block right here, and our quarterback was going to throw the ball. The way it worked out, I was open, and the quarterback saw that, and he threw the ball, but it was way too far for me to catch. So I kept my feet in. I used my school color. Kept my feet in, reached out, and as the ball came in, kept my feet down and caught it. The whole crowd cheered. It was an amazing play. One of the best catches I've ever had in my life. I gained 15 yards. We got a first down. We were going to go ahead and keep playing. Then, of course, this person right here, who used to be my friend until this happened, at the end of the play, one of the San Marino players decided to push him. So he thought it would be a great idea to go ahead and punch him back. Obviously, the ref saw that, and as I'm about to celebrate my great catch, he throws a flag or penalty on the field. 15-yard penalty from the end of the play, which means we go all the way back to here. So really, my incredible catch gained us 0 yards, and it was a bummer. But we did win, and I still made that great catch. So I think of it as a positive. So that's our anticipatory set. And sort of see how that fills in a little bit as we go on through our lesson right now. Now, let's go into our second part of our 7-step lesson, which is our standard. And our standard today is going to be 7.NS.A.1. That can be a little confusing, so let's break it down. 7 is for 7th grade. NS is the number system. So whatever we're talking about today, we're talking about the number system. Then we have standard A1. So it's a specific standard of our 7th grade California Common Core standards. So our standard for today, and I want everyone to write this down with me, is to describe situations in which opposite quantities combine to make 0. For example, a hydrogen atom has 0 charge because its 2 constituents are oppositely charged. So that's our standard. Since this is a recording, you can always pause it, go back and look at it. I understand that my handwriting is not the best, but you'll get used to it. Now, because of this example it gives us an ability to use one of our gate icons. And the one we're going to use is going to be the one that we call across disciplines. So what that is a circle, square, triangle with a dashed line through it. So that gate icon that we use whenever some of our domains cross into other subjects. So in this case, our math is going to cross over into a bit of science. So that's what we're looking at right here. So I'm going to go ahead and draw what a hydrogen atom looks like. There's a nucleus in the center, and then there's a shell outside that has different pieces in it. Now, in the nucleus in the center, we have protons and we have neutrons. Protons are positively charged, so you're going to get a positive charge. There's only one proton in a hydrogen atom. Now, the ones circling are called electrons, and they have a negative charge. In a hydrogen atom, there's only one. So we have one positive charge and one negative charge, which gives us a neutral charge, which is the charge of 0. So that's one way that what we're talking about now is going to cross over into science. So let's go ahead and move on now to the big part of what we're doing for our notes, which is called input. Input. Now, normally, when we do input, what I have to say is that there's no talking. As we're doing our input, you are listening and you are writing, but you do not talk. Now, because this is an online class, it's kind of nice, you can't talk. So, ha 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 ha, input. So in our input, we're going to go ahead and get all the knowledge we need to know. And the way that's going to start is with our gate icon, oh boy, which we call language of the discipline. And our language of the discipline is this icon, which is lips. I know it does not look like lips, but Mr. Barry is not an artist. So there we go. Those are lips, and that's how we know our language of the discipline, or our vocabulary, our words that we need to know. So the first one I'm going to do is one that we should probably know, and it's a whole number. A whole number is pretty basic, and all a whole number is, what matters to us is it is a positive number. A positive number. Now, this positive number can't be a fraction or a decimal. It needs to just be a positive number, a positive whole number. So think about it in terms of you need something physical. My favorite vegetable is carrots, and I can have 7 carrots. That's something I can physically hold. Down here, I cannot have -7 carrots. Something I cannot have. I can't have -7 carrots. So that's all we need to know for our whole number. So that's it for that one. Our next one is a little bit more complicated, and it is a rational number. So we have a whole number, which is pretty simple, and then we have a rational number, which is less simple, but still it gives us some rules to follow so we always know what a rational number is. And a rational number is a number that can be written in the form A over B or -A over B. Now there's some rules with this too, where A and B are whole numbers and B does not equal 0. So those are our rules of finding a rational number. Now those are some specific rules we need to follow, but many of the numbers we know can be written as a rational number. So let's go ahead and look at a few examples of what we can write as rational numbers. Let's say the number 3. The number 3 can obviously be a rational number. We can write 3 as 3 over 1, which is A over B. A and B are both whole numbers, and B does not equal 0. -3 can also be a rational number because we can write it as -3 over 1. Again, it follows those rules. 2 over 7, 2/7 can absolutely be a rational number because it's already written that way. -2 over 7 is another one because it follows those same rules. Then we have 4.6. And that one is also a rational number because you can write this as a fraction. 4 and 6 out of 10, or if you convert it all the way, 46 over 10. And that's our rational number. So that also means that -4.6 would also work as a rational number. So what's something that can't be a rational number? We can go ahead and see, let's say if we did 6 over 0. That is not a rational number. 6 divided by 0 is not rational. So that is not a rational number. B in that case equals 0. All right, so that's our second language of the discipline. Now I'm out of room on this page, so I'm going to go ahead and change pages. But I'm going to continue writing my notes. And I'm going to keep these notes together. Okay. So the next one we're going to go ahead and write is the absolute value. The absolute value is one of my favorite ones because it sounds confusing, but it's pretty simple. And an absolute value, all an absolute value is the distance from a number to 0. That's it. How far is the number we're talking about from 0? Now, if we look at this on a number line, we can see how this works. 2, -1, -2. So as you can see, this is our positive side, and this is our negative side of the number line. If we go ahead and write 2 numbers on this. First of all, we take 1, 2, and this is going to be 2. we go the other way, -1, -2, we're going to have -2. However, both of those have only done 2 hops. So their absolute values would be 2 because they're only 2 spaces away from 0. Another way to think about this, which actually my dad showed me, so I have to give him the credit, is as an elevator. If you get in on the ground floor of the elevator, this is the ground floor or the 0 floor, and you take it 2 floors up, you get off on the 2nd floor. If you take it 2 floors down, it's probably going to be P2 because it's a parking garage, but you're still 2 floors down. Whether you're going up or down, whether you're going positive or negative, it's still only 2 floors. And the way we say absolute value, we say or write absolute value like this. -3, the absolute value of -3, or the absolute value of 3. Any number with these 2 lines on either side of it is asking for the absolute value. So in each of these cases, how far is -3 away from 0? 3. How far is 3 away from 0? 3. Both of those would be 3. So that's how we write absolute value. Our next term is an integer. An integer. An integer is positive and negative numbers, including 0. So an integer is any positive or negative number, and it also includes 0. Now that seems like it's going to cover a lot, so let's go ahead and get some examples of this down again. -15, yes, it's a negative number. 27, yes, it's a positive number. -4, yes, it's a negative number. 5, yes, it's a positive number. 984, yes, it's a positive number. 0, yes, it includes 0. How about 4.6? 4.6 is not a whole number, so we can go ahead and say it will not be that. It needs to be a whole number, a full-on number, not just something that's positive or negative. So that's how we distinguish what an integer is. All right, next, let's take a look at our next term, which is going to be actually our last term, and that is our additive inverse. In our additive inverse, if we want to know what our additive inverse is, it is the opposite of a number. The opposite of a number. Now, if we want to get an example of this, I think you can probably all figure out what an example of an additive inverse is. But an example is, if we're looking for the additive inverse of -3, the additive inverse would be 3. If we had 1/5, it would be -1/5. It's just the opposite of the number. So the additive inverse is the opposite. In other words, what can you add to it to make 0? Oh, I remember our anticipatory set now. All right, that's all of our terms, but we still have something we want to look at so that you're not confused on any of the homework that we have. And that's where we're going to bring in another one of our icons. This icon is a flower. And this is for details. Details. Part of our input is our details. These aren't terms now. These are ways to remember things, stuff I need to tell you. So this is our details. That's with a flower. So let's go ahead and see. Now again, I think this is super complicated. So pay attention. So if I have a tree, and I'm standing, I won't be the same color as the tree, I'll be something. I'm standing in front of the tree. And on this, in front of this tree, for some reason, there's a number line. That's 0, 2, 3, 4, and I'll bring it out to 5. -1, -2, -3, -4, -5. Now, if I'm standing in front of a tree and I walk 5 steps, 1, 2, 3, 4, 5 steps, or -5 on the number line, and then I say, you know what? I kind of want to go see that tree again. And I go 1, 2, 3, 4, 5. I'm back at 0. See how complicated that is? There we go. Oh, I get it now. Super complicated. That 5 minus 5 equals 0, or that -5 plus 5 equals 0. But that's okay. Now, another way, and because it is football season, there's another thing. And actually, I think those of you at Chino, Coach Roach does this. Those of you at SOC, Coach Barton definitely does this too. One of the athletic things that we do in PE is we do the shuttle drill. Everybody loves the shuttle drill, but it is also a football drill. So if you are standing here, ready for your shuttle drill, the way he has it set up is that you start here. You need to run to the cone, and we'll say the cone's over here. There's another cone the same distance away on the other side. And what you do, that's the same distance, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, perfect. And what you do is you have to run as fast as you can to this cone. You run 6 paces. Normally it's about 7 yards, but 6 paces we'll say for this one. And then you have to turn around and you have to run all the way back over here. And then you turn around and run all the way back, and he counts your time as you cross that middle. So on this side, you've gone 6 and back 6, you're back at 0. You've gone 6 and back 6, you're back at 0. And that's the way the shuttle drill works. Same thing that we're talking about here. I'll even write underneath it, shuttle drill. So I think we probably have an idea of what we're talking about here. You'll understand where we're at here. So we're going to go ahead and move into one of our other steps here. And I'm going to have to bring another piece of paper. That's okay. We're saving a lot of trees as it is. So let's go ahead and use another piece of paper. And we're going to go into modeling. Modeling. And in modeling, we're going to go ahead and I'm going to do an example of a question you may see on the homework or the test. And when you see it, you will solve it exactly like this. So far, you should have exactly what I've written down on my papers, down on your papers. So let's take a look, and we're going to take a look at 3 different questions. Number 1, we have this. So we're looking at this. What this is asking is which number has a higher value? Which number has a higher value? And as we look at this, you've all should have done things like this before, where you put either greater than, less than, or equal to in this circle. Now, normally, if I give you 3 and -4, we all know that 3 would be more than -4. But that's not what these lines mean. Let's look at these lines, and if you need to, you can always go back in your notes. And I remember here where I wrote absolute value, and then I talked about this absolute value. The absolute value is how far away from 0 are each of these numbers. 3 is 3 away from 0, and 4 is 4 away from 0. It doesn't matter that this is negative. It's asking for the absolute value. So which absolute value is higher? It's going to be 4. This is the higher number. The higher value, because it is the absolute value. How far from 0? 4 is 4 away from 0. So that's number 1 on our modeling. Number 2, I'm going to give you a number. A equals 5.621. And then the question is, where does it fit? Where does it fit? And then there's going to be whole number. There's going to be integer. And there's going to be rational number. And as we're looking at this, I need to decide, is it going to go into one of these, more than one? Is it going to go into all three? What is this number? If I look at it, I know it can't be one of them because of the definition. 5.621 does not, it's not a full number or a whole number. So it's not going to be a whole number, so I'm not going to put it over there. Is it an integer? Well, I remember if I look back at my notes that an integer is a positive and negative number including 0, but it is not decimals. So if I look back here, it is not going to be an integer. So it's not a whole number, it's not an integer. Is it a rational number? Can I write this as a over b with a and b both being whole numbers? Well, let's see. I could write it as 5 and 621 over 1,000. Now, can I get this 5 away? Yes. It would be 5,000. So it would be 5,621 over 1,000. A and B are both whole numbers. Is B 0? No. So this is going to go into the rational number, but it won't go into any of the other ones. That's number 2. And finally, I saved the hardest for last. So prepare yourself. I'll give you a second. Breathe. Okay. Hardest question. 7 plus -7 equals what? Now I know what you're thinking. You are thinking, oh my gosh, Mr. Barry, I have no idea what this could possibly be. But I'm sure you'll be able to figure it out. All right, obviously I'm kidding. 7, and we can even look on our number line. 1, 2, 3, 4, 5, 6, 7. Draw my line too. If I go 7 this way, and then I'd say -7, 1, 2, 3, 4, 5, 6, 7, my answer is going to be 0. So hopefully that was not too difficult for you. That is the end of what this lesson is. Now what I do at the end, now the one step we're missing, and this is what I want you to do when you're doing it at home, when it's not a workshop, but when it's a pre-recorded workshop, we can't do it. A pre-recorded workshop, we're skipping over check for understanding. Now in check for understanding, you'd give a few sample problems just like these. You'd check to make sure you're right before you move on. So we're going to go over that, and now we're going to our 6th step, which is guided practice. And what you are going to do for your guided practice is you are going to go onto Pearson Realize. You're going to go to pearsonrealize.com. That's what we logged into last week. You're going to log into your account there. And when you get in, you will see that you have access to so much on that site. But I've assigned one thing for you. The thing that I've assigned for you is lesson 1-1 homework. Now the way that works, if you have any questions, you can email me, you can let me know. But the way this works is when you log in and you go to that homework, you'll answer questions online. And when you hit check, it will check to see that you are right. The questions will look similar to some of these things. You'll be able to check and make sure you're getting each one right. So that's our guided practice. When you finish that, your independent practice is going to be on Front Row Ed. So you're going to go to Front Row Ed. You're going to go ahead and go to Assigned Practice. And then you are going to select the one that says 7.NS.A1. And you're going to click that. You're going to go through and it's going to give you 10 questions. based on this kind of information. When you complete that, you are done with your math lesson for the day, and you can go ahead and submit this assignment online. And actually, I mean, mark as done. There won't be anything to submit. Now, please remember, these notes I want you to keep. The times I come on campus, part of what we're doing is I may ask you to bring your math binder, and you're going to have to show me all of your notes. And that's going to be an assignment. So please make sure that you are writing these notes out and you are keeping them in a binder somewhere. So that's the end of our lesson for today. This again is our guided independent practice, which you are finishing right now. Thank you to all of those of you who sent us some nice email thoughts about the flood. It was a very strange time, but it should be calming down now. We got through this broadcast okay. So I'll be posting this. Thank you very much and have a great day. Go Buffs.